Hi, 7th grade. Welcome to lesson 3-1, Analyze Percents of Numbers. By the end of the lesson, I want you to be able to say, I can find and analyze percents of numbers. Let's solve and discuss it. Jamie's older brother and his 3 friends want to split the cost of lunch. They also want to leave a 15 to 20% tip. How much should each person pay? Which line in the receipt will you use to calculate the tip? So you should calculate the tip from the total. So I want you guys to pause the video and try and figure this out on your own. We will ask for some participation and press play when you're ready. Okay, so if we wanted to leave 15%, well, 15% is 15 over 100. And I want to know, what is that amount over the total amount that we have, 78. There's a few ways to do this. And now if you wanted to leave a 20% tip, you would put 20 instead of the 15th, and so on and so forth. One way we can do it is by cross multiplying. That would give us 100 times x, which is 100x, equals 78 times 15. Now, 78 times 15 equals 1,170. To get x by itself, the 100 is being multiplied to the x, so we need to divide it. That will cancel it out. So it would tell me that x equals $1.17. That doesn't sound right. No, sorry. Silly me. $11.7. Okay, so that's how much tip they should use for the bill. But how many people are there? There are 4 people. How much should each person pay? We're going to take that 11.7 and divide by 4. That gives me 2.925. That's not a correct dollar amount though, so we're going to round that to 2.93. How would the amount of each person pays change if the tip is determined before or after the bill is split? Well, we just found out what happens when it's before the bill is split. But it would change if it was after the bill is split, because not everybody bought the same food, so not everybody would pay the same amount. So not everyone bought the same amount, which means that the total, this number that was here on the bottom, for each person would be different. So even if all of them were choosing to pay 15%, 15% of a bigger number is going to be bigger than 15% of a smaller number. Example number 1. Find percents of numbers. Diego starts a 12-hour road trip with his phone's battery charge at 75%. Given his normal usage, will his phone last the whole trip? Explain. So look for relationships. How many hours will the phone last when the battery charge is at 75%? So the information that they give us is that 100%, there's 15 hours. We want to know at 75% how many hours are there. So we're always going to go back to this whole thought of part over whole. So 75 over 100 would be 75% over 100%. There's the part, there's the whole. And then in the green here, it's talking about the hours. Well, we don't know how many hours it's going to last, but we know the total charge is 15 hours. So their way of solving it is to just get x alone, and they see that x is being divided by 15. So we got to use the inverse operation to multiply by 15 on both sides. What I'm going to focus on is the process of cross multiplication. So I'm going to show you, and you should write this down as well. Same setup, 75 over 100 is equal to what over 15? That x is what we're trying to find. So we cross multiply. And we do 75 times 15, which gives us 1,125 equals 100x. Now we're trying to get x by itself. X is being multiplied by 100, so the inverse operation is to divide by 100. So then X equals 11.25, which is the same answer they got. So you can use either method. Now you have two strategies on how to solve this. So the remaining battery life is 11.25 hours, so his phone is not going to last the whole 12-hour trip. Kita's phone had a full charged battery. With normal usage, her phone will last 18 hours. How much time is left on Kita's phone battery with a 12% charge remaining? So this part is talking about our percentage, and this part is talking about the hours. So what number is going to go above the 100? 12. And what number is going to go below the X? What is our total amount of hours? 18. Remember, part over whole. So going with their method, we'll keep the 12 here and the 18. We know we want to get X by itself. So we see that the 18 is bothering the X. And right now the X is being divided by 18. So in order to get rid of it, we're going to multiply by 18. That's the inverse operation. So these would cancel out and we're just left with X on the right hand side. And then we do 12 divided by 18. 12 divided by 100 times 18. So that's 2.16. So that means Kita's phone battery has 2.16 hours remaining. Let's try it our way. Cross multiplication. 12 over 100 equals X over 18. Make your cross. 12 times 18 gives me 216. 100 times X is just 100X. Always trying to get X by itself. 100 is being multiplied by X. So we're going to divide it. And we get again, X equals 2.16. So you can use both methods. You can use one method to check, or you can pick your favorite. Why is 51% of a number more than half of a number? Well, half of a number is 50%. And 51% is greater than 50%. Example 2. Use percents greater than 100. A full set of adult teeth includes 160% as much teeth as a full set of baby teeth. How many teeth are in a full set of adult teeth? Use the bar diagram to write equivalent ratios. Then solve for t to find the number of teeth. So we know that there's 20 baby teeth. That would be the 100%. See how the red and the red line up? So we should see 120 on both on the denominator. Then 160% is how many total adult teeth there are. So that goes on the top. Again, they're trying to solve for their variable. So they multiply by 20 on both sides. We can cross multiply. Cross multiply, I'll show you, 160 over 100 equals t over 20. 160 times 20 is 32. 100 equals 100t. Divide by 100. T equals 32. And I think you guys should know that. Or if you haven't, then you'll learn it soon. Full set of adult teeth includes 32 teeth. Now using percents less than 1%. What is the approximate distance in miles from the Earth to the Moon? Well, we know the whole thing is 93 million miles. And that's 0.27 of the distance between the Earth and the Sun. So 100% is going to be that 93 million. So that's why the 93 million and the 100 are both on the bottom. Remember, we got to line them up. We want to know what the distance is from the Earth to the Moon, so that's x. But we do know it's 0.27%. So it's always the percent over 100. So they do multiply by 93 million. We can cross multiply x over 93 million equals 0.27. Another thing to remember, the percents are always together. So if it says percent, 9 times out of 10, it's going to be over 100. The only time it's not is when the percent is bigger than 100, but it's still over 100. Like, it's going to be 160%. Think about the word percent. The beginning says per. That tells me to divide. And cent, I think of like 100 cents in a dollar. So it's always divide by 100. Okay, so we can cross multiply. We get 100x equals, now in my calculator, I take 93 million and multiply it by 0.27 to get 25,110,000. Next step, or last step I should say, is to divide by 100, and you will get x equals 25,110, which is the same thing they got here. Oh, no, silly me, again. Classic. See how that check didn't work? All right, let me try my math again. Divide by 100 should give me 251100. So 251,000. Let's try it. I want you to try these ones on your own. I'll help you set up the first one. So it says find 0.08%. Whenever you see that percent, I want you to think divide by 100. So that's what we're going to say. 0.08 over 100 equals, now we don't know what that is, over 720. Same thing, I'm going to help you set up all three, then I'm going to have you pause the video and try on your own. So 162.5%, little light bulb. 162.5 divided by 100 equals what over 200? And last but not least, 0.3% equals what over 60? Now you don't have to use x as your variable. You can use any number. All right, check your answers. For the first one, you should get, let me see, okay, so we cross multiply. So we do 0.08 times 720 divided by 100. 0.5576. Then again, cross multiply. 162.5 times 200 divided by 100 equals 325. Last one, 0.3 times 60 divided by 100 should equal 0.18. Okay, key concept. Percent is one way to represent the relationship between two quantities, generally that part to a whole. Part over whole. All right, 7th grade, let's go over and say it. I can understand, find, and analyze percents of numbers. Have a super great day.